In this short video lesson, we're going to talk about imposter diagrams. These are diagrams that look like Venn diagrams, but they're not. So in previous lessons, you've taken a look at the basics of Venn diagrams, how to overlap those circles, use pinstripes to indicate that there's no members in a particular area, put a little X to indicate there's at least one member of an area, and that's about all we'll need to move forward in this class. The interesting thing about Venn diagrams that set them apart from other diagrams is that they're specifically designed to represent all logically possible relations between sets. Now, that's not something we need to focus on in a way that we thoroughly understand what that means in this class. It's just that's a distinctive feature, a necessary condition for being a Venn diagram. And so we're going to look at a couple of types of diagrams today that look like Venn diagrams, but they don't meet that condition, and so they're not genuine Venn diagrams. Okay, so the key upshots from this video lesson is that not every overlapping circle diagram is a Venn diagram, and not all Venn diagrams are composed of overlapping circles. You can make a Venn diagram using just about any shape you want, and indeed, after you get above 3 circles overlapping, you're really forced into using other shapes in order to represent all the logically possible relations between the sets you're representing on your Venn diagram. Okay, so the Venn diagrams we're going to be talking about are the type of diagram that were developed by logician John Venn, and they are John Venn's diagram. That's where the name Venn diagram comes from. Okay, so in order to make this as simple as possible, let's just imagine that you've been tasked with teaching a young child their shapes. In order to do that, you're going to have an understanding on your own of what the different kind of shapes are, right? And we get the definitions of shapes from geometry. And you're probably not thinking to yourself these technical definitions if you're teaching a young child their shapes, but it's still important to understand that these are the way that the terms you're using when you say, here, little, Angie, this is a circle and this is a triangle. You're only going to be correct insofar as you're obeying these definitions when you try to help her identify these shapes. So by the definition of circle, what we have is a circle is defined as a shape that consists of points in a two-dimensional plane equidistant from a given center point, so equidistant from the center point. Then you get this closed curve that has no sides and no vertices. Okay, that's what it is to be a circle. So any shape that satisfies that definition counts as a circle. Meanwhile, a triangle is defined as a three-sided two-dimensional shape whose interior angles are equal to 180 degrees. Triangles have 3 vertices and 3 sides. Okay, so 3 little points there, 3 internal angles, and 3 sides. 1, 2, 3. Okay. Okay, now let's imagine we have to put these shapes onto our Venn diagram here. It's pretty straightforward where our circle should go. We can choose between these two regions, region 1 and region 2. Both of those would be inside the area where we're supposed to put all our circles. And we have to decide between region 1 and region 2, where should we put this shape? Well, in order to fall into region 2, it would have to satisfy all the conditions for being a circle, which it does. It's round, it has the center point with the equidistant points around that center point, and no vertices, no sides. But it's because it has no vertices and no sides that we cannot put it into region 2, because anything in region 2 would count as a triangle. But this is not a triangle. It doesn't satisfy the conditions for being a triangle, and that's why we have to put it outside of the circle here, but inside of this circle here. So the only way we can do that is put it into region 1. All right, how about this little star shape? Well, the star shape definitely is not a circle. It definitely has sides and vertices. That rules it out from being a circle. And triangles can have sides and vertices and internal angles, but it has to have exactly 3. And this one has too many of those features to count as a triangle. So it can't be in region 1 because it's not just a circle. It can't be in this region because it's not a circle, nor is it a triangle. And it can't be in this region because it's not a triangle. So we have to put it into region 4. How about this shape here? The shape is very circle-ish, but to be a real circle, you have to have only a curved line on the outside. You can't have a side like this and a side like this and internal angles of this kind. So even though this looks like it has a triangle cut out of it, it's not really a triangle either. It does have the sides and it does have internal angles, but it's not the kind of shape that satisfies the definition of triangle. So it's not a complete circle, so it can't fall into this area here. It's not a triangle, sort of like cut the triangle piece missing, so it can't go into here. So the only place left to put it is on the outside. All right, so now we have our little three-sided shape here, three sides, three vertices, internal angles add up to 180. So this is the type of shape that belongs in the triangle circle here. And what we want to do is decide, does it go into region 2 or region 3? Now, to say that it goes into region 2 would be to say it qualifies as a circle, but of course it doesn't, because it has sides and vertices, and circles can have none of those features. So in order to stay inside the triangles with the other triangles and outside the circle, we have to put it into region 3. So we'll put it there. And then here's the question that we've been waiting for. What about this shape? It has like a hidden triangle inside of there, and it's at least halfway to a circle. So this one looks like it legitimately has a triangle and a circle smushed together. Where on the diagram should we put that? Now, based on my teaching experience, almost every student I've ever had who hasn't recently had Venn diagrams in a math class will put that shape into region 2 here, thinking that it's a little bit circly, it's a little bit triangly, and that's what we're supposed to think about when we put things into region 2, things that have some properties of this set of things and some properties of this set of things. Okay, but if you think back to what we said about these other shapes, right, that this one had some, circular aspects, and this one had some triangular aspects, but they didn't qualify it as a triangle or circle because they didn't meet all of the necessary conditions for being either one of these things, then our shape here really doesn't count either. Okay, it needs to be in region 4. And so this video is primarily for those of you who are not clear on why that little shape should belong in region 4. Okay, so one way of clarifying why that little shape has to be in region 4 is by separating the circles. And if we were just thinking about circles and putting all of the shapes that are circles into this area here, would you ever tell your little student here that this item is a circle and she should put it in with the other circles? No, obviously not. This is not the kind of thing, these sides here and these sharp angles are just not the kind of features that a circle could have. So this does not belong in with the other circles. Would you tell the little kid that, here you go, honey, this is what a triangle looks like, put it in with the other triangles? No, you'd be a bad teacher if you did that, because triangles have to have exactly 3 sides, and this one doesn't have a side here. It has this like curve thing, and the internal angles are not going to add up to 180 here, right? And so we don't have a triangle or a circle, and you can see that when we separate the circles for the triangle and for the class of circles. Okay, so again, it's based on the definition of a circle and the definition of triangle that we're making this determination that this item here doesn't qualify as a circle, and it's a non-circle, and so it belongs outside of the class of circles, and it doesn't satisfy the definition of triangle, so it's not a triangle, it's a non-triangle, so it belongs outside of the class of triangles. Okay, so going back to our attempt at putting this shape into a Venn diagram, and now it's maybe easier to see why this little shape does not belong in region 2 on a Venn diagram. If we take the triangle, if we take this light blue circle away that represents all of the triangles, what you've done by putting it in region 2 is basically said that this is a circle. Okay, so when you remove that the circle that's representing the set of all triangles, we can see what we've done and we can see the mistake, and it's easier to say, okay, obviously that's not a circle, we need to take it out of that set. All right, we can do the same thing again, but removing the other circle. And so we take that then circle off. And now we can see that putting it into region 2 would mean that we've classified it as a triangle. And since you would never tell a little kid that this is a triangle, you can see very clearly that we've made some kind of mistake. And that belongs outside of the set of all triangles. Okay, so now we have our Venn diagram set up where we can see where all the shapes belong. And we understand that a shape like this that is a little bit triangular, it has some triangle features and it has a little bit of these circle features here, that this kind of shape does not belong in region 1 because it's not a real circle. It doesn't belong in region 3 over here because it's not a triangle. It doesn't belong in region 2 because it's not both a circle and a triangle because it's neither. And it does belong in region 4, which is where you put the things that are neither circles nor triangles. They fall out of both of those categories of things. So we put it into region 4. That's the place that you put it onto a Venn diagram. Right? So when you're putting the shapes in, you have to use the definitions. The shapes that don't satisfy the circle definition don't get to go into the dark blue here, and the things that don't satisfy the triangle don't get to go into the lighter blue. And remember, when we're doing Venn diagrams, what we do is we write an X to say there's at least one thing that's in this region, and there's at least one thing in this region, right? So for our Venn diagram here, this X would represent the blue circle. This X would represent our orange triangle. And then we could add a little X here for our teardrop shape. And then the question is, are we done? And not quite. We could say more based on the definitions that we have here. We can also say that basically it's impossible to have anything in region 2 because there's nothing that could exist that has no sides but also 3 sides and no vertices while it also has 3 vertices. So there's nothing that could have no sides while it has 3 sides. Okay, so we use pinstripes here to mark that, to let people know don't put anything in here. Nothing's going to fit into there because nothing's going to be able to satisfy the definition of circle and triangle at the same time. All right, now we have a basic review of the Venn diagrams where we're putting the shapes on in the correct way. Now let's take a quick look at our first imposter diagram, what I'll call a blender diagram. All right, so hopefully some of you already know this, but yellow and blue are primary colors. And when you mix them together, they turn into a new color, green. Okay, so in color theory, they have primary colors, and then you can mix those to get secondary colors. And this is another way of putting the point that yellow and blue make green. Okay, so you have these two primary colors, you mix them together in different percentages, and you get different shades of green. All right, so what's a blender diagram? Well, in a blender diagram, the items in region 2, in the overlap here, they're things that have a mix or a blend of the properties associated with being a member of the class represented by each individual circle. Okay, so if this is where all the yellow things are, and this is where all the blue things are, the things in the middle, as the color here represents, are the things that are kind of greenish. They have a little bit of the yellow, they have a little bit of the blue, and together that makes green. Okay, so if we had a green polygon like this, it would go into region 2. So how do we compare the blender diagram to the traditional John Venn diagram? Well, on our blender diagram, the things that are genuinely pure yellow would go in this outer area here. This little green guy would go in the middle to say he's a mix of the yellow and the blue guy would go out here in region 3. And now we can think about where to put these same shapes on our genuine Venn diagram. And hopefully it's clear now that on this diagram, yes, the yellow thing goes into the area here for yellow things. It can't, this shape doesn't go into here because it's not a blue thing. The blue shape is represented by putting an X out here in region 3. We can't put it in here, even though that's a part of the blue, set of blue things. That's a possible place that blue things could go according to our diagram. We can't put it there because that would mean that it's a yellow thing, but obviously this is blue, not yellow, so we don't want to put it here. And this little green shape, rather than putting it into the middle where it would be a mix of yellow and blue things, in a Venn diagram, if it's not a genuine yellow thing and it's not a genuine blue thing, it doesn't go in the middle, it goes in region 4 on the outside of both. Okay. Now the next imposter diagram is what we'll call a CC diagram or a compare contrast diagram. Now this is probably something that you've learned in an English class in K-12 at some point, and there are a lot of learning materials that say that these are Venn diagrams, and they're really not. Okay, this is a classic imposter diagram, and we'll take a look at why here quick. These diagrams that are given in English classes are typically used to show that there are certain properties that things of two kind have in common and properties that make them different. Okay, so in an example like this, we have a compare contrast diagram with whales and fish as our main categories. And what are some distinctive things about whales that fish don't have? Well, they have live birth if they're young, they have to breathe air, and they have hair. Okay, fish, in contrast to whales, fish have scales, they lay eggs, and they can breathe through the water, right? So I didn't come up with these properties; these were borrowed from the original diagram. Okay, and so in the middle here, what we do is we put properties that they have in common, right? So they can both swim, they both live in water, they both have fins. Okay, so the compare part, we put everything that they have in common in the middle, in region 2, and the contrast, the things that are distinctive of whales that fish lack, we put here. The things that are distinctive of fish that whales lack, we put here. All right, so if you're looking at a diagram that is working this way, this is not a Venn diagram. For purposes of this course, we're going to call these compare and contrast diagrams. That's basically what they're already called, or a CC diagram for short. All right, so if you have a CC diagram that looks like a Venn diagram, that's going to be more confusing because you're going to have to try to think of, well, is this just a badly formed Venn diagram or is this a well-formed CC diagram? And so one way to fixing that problem is you could just use a different shape for CC diagrams for compare contrast. So let's take a look at how we would do that translation from our overlapping circle diagram into this CC diagram. We would put whales and fish as our categories. So fish is everything in this area, and whales is everything under this yellow area. And our contrast areas are up here. So things that are distinctive of whales that fish don't have go up here. Things that are distinctive of fish that whales don't have go up here. And down here are the things that they have in common. Okay, so using the compare contrast features that we had earlier from our original example, our live birth, breathe air, have hair. Those are the things that whales have that fish don't. These are the features that fish had that whales don't. And these are the things that they have in common. And that's basically it. That's how you do a CC diagram. Now, to close out our conversation about CC diagrams, it's interesting to point out that you can translate a CC diagram into a Venn diagram. You just have to make sure that the categories that you're talking about here are properly stated. So instead of having just whales and fish at the top, if you wanted to do a Venn diagram version of the CC diagrams that we just did, let's use the example of whales and fish. You would actually have properties of whales and properties of fish as the names of your set. Okay, so then in that case, there would be properties that would be members of this of the regions here, so individual properties. So live birth, breathe air, have hair. Now these are each individual properties. They're things, and they're members of these sets. And so we could just represent these properties using X's, just like we standardly do with Venn diagrams. And we've got a properly formed Venn diagram. And all we had to do is just kind of update and be more careful with the categories um, that we're describing here to make sure that the things that are inside of the Venn diagrams are the right kind of things, and that we're thinking about the meaning of these circles in the right kind of way for this to qualify as a Venn diagram. So hopefully that helps you step back if you learned these to conflate Venn diagrams and CC diagrams and see that they really aren't the same, even if they often look the same. And we've taken a look at how to make them look different to make it easier to remember that they function differently and there's different rules for filling them out. And the big upshot again is just that when you see two overlapping circles, it doesn't mean that it's a Venn diagram. There could be different types of diagram that are perfectly good, right? A blender diagram, a CC diagram, they're perfectly good diagrams. They just have different rules about how to fill them out than a Venn diagram. So there's no reason to conflate them. And it is wrong to call a blender diagram a Venn diagram. It's wrong to call a CC diagram a Venn diagram. They just have different functions. They have different rules. Okay, so just keep that in mind as we move forward. In class, what you'll want to use when I talk about Venn diagrams are the Venn diagrams that we've covered in class that are legitimate Venn diagrams. Okay, so don't use blenders or CC diagrams when I ask you to make a Venn diagram on a discussion post, for example, or answer questions on a logic lab. Those will be marked wrong. And this is a really important point. So make sure that if you don't understand this, that you head to office hours to make sure that you've got this all clear before discussion 1. We're not getting into the logic here deeply enough for you to really recognize a lot of more complex Venn diagrams as Venn diagrams. But there are lots out there, and as we've talked about, you don't have to have circles. A lot of times you get weird shapes, ellipses. You could use triangles if you wanted to. It just gets a little bit uglier, and that's about it. It's fine to use other shapes as long as you're representing all the logically possible relations with those shapes. And then there are diagrams that have overlapping circles or other shapes that aren't Venn diagrams, right? So here's some Euler diagrams. These are perfectly good diagrams. They're predecessors to the Venn diagrams, but they're not Venn diagrams. Okay, so we'll just want to kind of keep that in mind, that there are lots of different non-Venn diagrams that are perfectly good diagrams that you just don't want to confuse with the real ones for purposes of the class. So hopefully what you've gotten out of this discussion is a clear sense of the line between the kind of diagrams that fall inside the set of Venn diagrams and those that are not allowed in, so that this line here is a little bit sharper in your mind. Okay, this is the end of the video, so all you'll need to do is follow the instructions on the screen and keep these distinctions between the imposter diagrams and the genuine Venn diagrams in mind, especially on your first discussion. And if you have any questions about how to avoid using blender diagrams or CC diagrams on your first discussion when you're going to be asked to create a Venn diagram, you are welcome in office hours to go over these concepts to make sure you've got them all the way down and perfected before you submit anything for a grade that has to do with these Venn diagrams and their imposters. See you next time.